I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to discuss the topic on curl of a vector and Stokes theorem for the course Electromagnetic Fields and Waves. So now we are going to recall the previous topic, divergence. Divergence means spreading or convergence of a vector field. It indicates the presence of either source or it is a sink. So it is a scalar quantity obtained from a vector field. For example, if we take a vector as A, then its divergence can be given as del dot A. So this is about divergence. And next, we are coming to the today's session. So the various concepts involved in this discussion are concept of curl, mathematical definition of curl and its physical significance, curl in electromagnetic field, and the Stokes theorem, application of Stokes theorem in electromagnetics. So now we are going to discuss this curl in design thinking way. So we are going to see the first component, empathy. So the empathize part, the curl means it is a measure of rotation or circulation of a vector field. It indicates the tendency of a field to rotate about a point, and this is a vector quantity obtained from a vector field A as del cross A. So del cross A is the symbol of curl. And now we are going to see its physical significance. We can define the vector based on the curl. For example, if curl is not equal to 0, we can say the field is a rotational field. And if curl is equal to 0, it is a irrotational field. And the direction of the curl indicates the axis of rotation, and the magnitude of the curl represents the strength of the rotation. So this is about the physical significance of the curl. So now we are going to define this curl in mathematical way. So for example, take a vector field A as Ax I vector plus Ay j vector plus Az k vector. So we can define curl in mathematical way as del cross A equal to the matrix form. Determinant of matrix I j k is the first row, dou by dou x, dou by dou y, dou by dou z the second row, and third row contains the magnitude of the vector in three directions, ax, ay and az. And del cross A gives the resultant is a vector field, and the direction of curl represents from the right hand rule. And now in the defined part, curl in electromagnetic field is used in various forms. So mathematical curl equations involved in Maxwell's equations. We know Maxwell's equations defines the existence of electromagnetic equations. So they are four mathematical equations. In four mathematical Maxwell equations, two are curl equations. One represents curl of the electric field, the another equation represents the curl of magnetic field. So the curl of electric field equation of Maxwell's equation is del cross E is equal to minus dou B by dou T. So here E is the electric field, and B is nothing but the magnetic field intensity. And next is del cross H. So this shows the rotation of the magnetic field, and it is equal to two types of current density. One is J, that is called as conduction current density. It is equal to sigma into E, and it is added with the another type of current density is displacement current density, dou D by dou T. So here D is electric flux density or displacement density vector. And so this is the use of a curl in Maxwell's equations. There are two equations. One is del cross E and another one is del cross H. And these two equations shows the relation between electric and also the magnetic fields. So now the very important theorem based on curl is Stokes theorem. And Stokes theorem relates a line integral to surface integral, and it converts a circulation into a curl over a surface, and it is useful for simplifying electromagnetic field calculations. And the Stokes theorem given by integral over a contour uh, a dot dl, that is line integral of a vector field A is equal to surface integral over a closed surface del cross A dot ds. So this is Stokes theorem. So this Stokes theorem converts a line integral of a vector into curl of its surface integral. And there are various applications of Stokes theorem in electromagnetic fields. This will be very useful in Faraday's law derivation, and also it is useful in Ampere's law and also the Maxwell's law derivation, as we seen already. So this curl also used in induced electromagnetic field analysis, and also useful in field circulation simplification. So these are the various applications of Stokes theorem in electromagnetic field. So from the applications we can know that how much useful this curl in the electromagnetic field theory. And now, so far we have discussed the curl in vector fields. We have seen the definition of curl and the concept of curl, and also its physical significance, how it is defined in mathematical way, and also we have seen how the curl is used in Maxwell's equations, and also we have see about Stokes theorem. So Stokes theorem is a very important concept in electromagnetic field, which converts a line integral of any vector field into its surface integral. And thank you.